Welcome to Module 5 of the OpenTelemetry eLearning. In this module, we will speak more specifically about the OpenTelemetry backend. First, we will define what is a backend and what are its purpose. Then, we will speak about the OpenTelemetry recommended architecture and why it ensures that you've got no vendor locking in terms of backend. And finally, we will illustrate the new capabilities offered by distributed tracing with some illustration from Lightstep backend and Lightstep screenshots. We will speak only about distributed tracing because this is a new capabilities, whereas monitoring with metrics or classic log usage are already known by most of the users. All this usage of different backends will be illustrated also by a lab where you will connect both to Jaeger and Lightstep and push to them all the telemetry data that you collected during the previous labs. First, let's explain what is an OpenTelemetry backend. In the previous modules, we explained you how to collect metrics, traces, and logs, and you did labs in order to collect traces from different services and push them to an OpenTelemetry collector. But once you've got this data, the purpose is to be able to use it and to store it so that you can query it in the future several days after you collected it. And by the way, when you collect metrics, you want to display them in dashboards. You want to be able to be alerted in case there is an anomaly or in case a metrics is going beyond a certain threshold. At the end, you want also to be able to use all of this data in order to do your root cause. And with the most modern solutions, you will be able to use artificial intelligence or correlation algorithm in order to target more easily what is the root cause of your problem, to analyze trends and to calculate KPIs, SLIs, and SLOs of your application. All these functions are typically handled by the OpenTelemetry packets. Whether you use a single solution, like Lightstep for example, or you split the different features in different solutions, like for example using a Prometheus to store all your metrics, then you use a Grafana in order to display them, and you use a Jaeger to display traces, it's your choice. And OpenTelemetry gives you the flexibility to do all this. This slide presents the recommended architecture by the OpenTelemetry community in order to deploy OpenTelemetry. On the left side, you've got all the agent SDKs and APIs that are used in order to push the information to the collector. The collector is used as a proxy in order to push back all this information to different backends. And that's where you can see that you've got no vendor locking, because in fact, you can use with a single collector many different backends and push in parallel the traces to different ones, or split the information between one tool to you for the traces and another one for the metrics. What is interesting here is that changing or adding a new backend is just few lines of YAMLs, as you will see during the lab. But if we want to present all the features that are used in OpenTelemetry, we can present them in three different layers. The first layer is the collection of the telemetry data. And that's where typically we use the OpenTelemetry agents in order to collect both metrics, traces, and logs. But then you need to send this information and you need to store this information. That's the second layer. And typically, you can use two types of database in order to store this information. Time series database for traces and metrics, and transaction database for logs or traces also. At the end, all this stored information will provide you value through the third layer, which is the layer when you've got all the screens, all the tools in order to use this information. So it could be dashboards, it could be graphics, it could be alerting, but it is also a correlating algorithm and analysis algorithm will provide you added values on your data. Let's see a little more how this information could be displayed, and for this we will illustrate typically with distributed trace. Here you can see the power of distributed trace in order to do root cause analysis of a problem. On the left side, you've got a single distributed trace regarding a bug or error, and you can see that you've got the full stack trace of all the operations that are called for this transaction, and when there is an error that is visible at the customer level on the iOS, you just have to go slowly to all the stack trace to find that this error is coming from a call to a database, simply because that is the line, the bottom line in red. And then you can go to the logs that are attached to the trace. On the right side, you've got a similar trace, but here you want to investigate a latency issue, meaning something that is taking too much time. And here again, it's very simple to find the root cause because it is simply the longest black line with Lightstep. So you can quickly identify where your latency is coming from. For sure, if you use different tools, you will have different GUI in order to show this, but typically, distributed traces are very useful because of this fast analysis and very easy analysis to find the root cause of a problem. Typically, you can use this trace also in order to give you all the dependencies of your services. And again here, on the left side, you've got the debugging for an error, and the right side, the debugging for a latency issue. The architecture diagram is quite similar because it shows all the stacks of your different services calling each other. But on the right side, you just have to see that you follow the red circle in order to understand where is the bottom line of the error, where is the root cause of the error. And for the latency, you just have to follow the biggest yellow circle because it represents the biggest latency. But again, very simple and very fast to find the root cause of a problem. What is interesting with OpenTelemetry is that you're able to send metrics, traces, and logs with a single agent. And by the way, due to this, you can also more easily correlate all this information, simply because the context or the attributes that you use for each of these items could be correlated together. So typically here, you've got a classic dashboard, a metric dashboard, where you can monitor your CPU, you can monitor your memory. But what is new with Lightstep and with distributed tracing is that you can correlate these metrics directly with the traces that are linked to this service. So when you've got several containers like this that goes higher on memory consumption, you can simply link this directly to the trace that are generating this error, and you will find which component exactly is taking the most memory. That was for classical dashboard, but when you go to microservices and cloud native, many organizations follow the SRE principle edicted by Google. And in this principle, Google recommends you to use the RED method and the RED metrics instead of the standard one. What are RED metrics? It is based on rate, error, and delay, meaning that you will measure the throughput of your services, you will measure the latency of your services and the error of your services instead of measuring only the saturation of your infrastructure. And why is it interesting? Because the RED metrics follow the customer experience. When a customer's got a problem using your application or your website, it is mostly because the site is too slow or because the site generates too much error. And that's typically what you will follow with these RED metrics. What is interesting with these new capabilities is that you can have dashboards that typically follow these RED metrics, meaning you've got here only the 3 KPIs that you need to follow to be compliant with the RED metrics. And when there is an error, because the error rate is getting higher here, you can directly link it to the trace because each point that is here is a trace where you will go directly to the root cause of the error. So that illustrates how you can very quickly go from a metric that is not going well and that is directly perceived in your customer experience to the root cause of the problem in just one click. Finally, we can speak about the correlation of all this telemetry data together and involve on the same page in a unified dashboard all traces, logs, and metrics at the same time. And that's typically what you see here. So this is again illustrated by a screenshot from Lightstep, where you've got in a single page the visibility for your metrics. Again, the red metrics, latency, error rate, throughput. But also, you've got your latency histogram, because performance is a key indicator. You've got your architecture diagram, where you can click on any layer, any operation, and you've got your context information. And at the bottom, you can see the log and the traces. When you first see this screen, you can see, wow, that's so many information in just one screen. But at the end, in fact, that's far more easier to use than any other tool where you've got all this different information in different tabs or in different tools. Why is that? Simply because all information is correlated together. Meaning that if, for example, you click anywhere in the architecture diagram to select a specific operation, it will directly impact the logs and the traces that are selected below. And that's the same for context. If you want to select a specific version, if you want to select the value of a specific attribute, it will filter automatically the logs and the traces so that you display only information that is linked to what you selected. And that's the most efficient way in order to do investigation on an incident without losing time. That's all for this module. Now I will let you practice a little all these features and the connectivity between OpenTelemetry collector and its backend with the module lab.